Hey guys, welcome to a new video. In today's video, we're going to look at a Leetcode problem, and the problem's name is Reorder List. So in this question, we're given the head of a singly linked list, and the list can be represented as L0, L1 through Ln-1 and Ln. So this is the input list given to us, and the task is to reorder the list in the following format. So after L0, we have to connect it to the last element. So this node should be connected with the last node. So 1 should be connected to 4, and next L1 should be connected to Ln-1. So this was L1, right? So 2 is here and it has to be connected to Ln-1, which is this. So 2 is connected to 3 and we connected all the nodes. So here in this case, as you can see, 1 and 5 should be connected, 1 and 5 are connected, then 2 and 4 should be connected, 2 and 4 are connected, and then 3 is connected. So let's take a look at this example and see how we can solve this question. So we are given the head of a single linked list, so our head is here. And now our task is to connect head.next to the last node. But how can you connect? There are these nodes in between. So you just can't directly go to the end. You have to play with the nodes and connect them. So one observation to make is that if you reverse half of the linked list, so if you find the middle node, so in this, the mid node is here, and reverse, and from the mid element, if you reverse mid.next, you will get 5 and 4. And you have your first part of the linked list. So now you have two linked lists. And this is your first linked list. So you have P1 and you have P2. So let's draw the two linked lists. So you have P1 pointing here and you have P2 pointing here, and this is the mid element, and you can directly connect mid to null before starting the merging, because here, as you can see, we already solved this part of the question by pointing mid element to null. So this is solved. We got this part. Now, and in the output, 1 is connected to 5. So 1 is at P1 and 5 is at P2. So 1.next should point to P2. So 1.next is this node and make a connection to P2. And now P1 and now P2 should point to this node, right? But there is no connection here. So initially you have to create another node P1 next, so that this P2 can point to, and now this P2 will move to P1 next, and P1 will move to P2, and P1 next will move to P1.next, and P1.next, so remove this connection, will point to P2, and we have to move P1 to P2, so P1 will come here and P2 will go to P1 next. So P2 is here and P1 next will go to here. And now repeat the same process. Remove this connection P1.next. P1.next should point to P2, right? And move P1 to P2 and move P2 to P1 next. And P1.next is at null. And now we have to proceed further. P1.next is this, right? We have to change that to P2. So P1.next will move to P2 and P1 will move to P2. And P2 will move to P1 next, and P1 next will move to P1.next, which is here. And now P2 is equal to null, so we end the iteration. And now let's form our output, which should match our expected output. So 1 is pointing to 5. So we have 1 which is pointing to 5. And now 5 is pointing to 2, and 2 is pointing to 4, and 4 is pointing to 3, and 3 is pointing to null. And this is our output, which is matching our expected output. Now let's implement these steps in a Java program. So this is a combination of 3 simple steps. So first we are finding the middle element. So this is the function to find the mid element. You're taking two nodes, fast and slow, until fast.next or fast.next.next points to null. Fast will move 2x speed and slow will move with 1x speed. Finally, when this condition meets, we come out and return slow. So slow will point to the mid element. So we're finding the mid element by calling this helper function. And next to mid is the mid node.next. So we find the mid element. So this is the mid, and next to mid is 4 and 5, because we need to reverse this. And initially only we're pointing mid node.next to null. So mid node, so we are making this connection, mid node.next is pointing to null. And now P1 is equal to the first half. So P1 is initially this node. And P2 is equal to reverse list of next to mid. So next to mid was 4, right? So from here we have to reverse. So I'm writing a helper function, which is a simple helper function which reverses a linked list. So these two methods are separate question. I'll leave a link to that videos in the comment section below. And I'm creating a node P1 next, so that we know where P2 should go next to. So until P1.next and P2.next are not equal to null, P1 next is equal to where P1.next points to, and P1.next is equal to P2, and we move P1 to where P2 is, and P2 will move to where P1 next is. And this will happen until this condition satisfies. And finally, you have your output list here. So time complexity of this approach is O of n because we're iterating through all the nodes once, and the space complexity is O of 1 because we're not using any extra space to solve this question. That's it guys, thank you for watching and I'll see you in the next video.